A few of you may have read my blog about 2.5 weeks ago, where I put out something like, I can't migrate my code to Unicode or Delphi 2009, or I forget what I said exactly. There was a lot of discussion going on back here for some reason.
We're not bothering you, are we, Alan?
Sorry.
Where it came from. And
Yeah. So anyway, basically, we hear from a lot of people that migration is fairly easy in 80-90% of the cases. But of course, in the 10% of cases where you have inline assembly and stuff like that going all the way back to pre-alpha Turbo Pascal 1.0 in your code bases, it might become an issue with migrating stuff to Unicode. So this is not even cooking in the labs. This is on my desk. Just playing with it. It's not checked in anyway. And basically how I started out with, I took something that nobody else seems to want to touch. I took the Async Pro stuff and I ported it to Delphi 2009. I actually have it installed on my machine. Keep in mind that I got it compiling and installing. It doesn't necessarily work properly. I did get the FTP demo to work. Yeah, exactly. And thank goodness there was tracing and stuff like that built into the FTP components, because otherwise I'd never had a clue that, I need to change this packet handler, blah, 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 et cetera, et cetera. Of course, when you migrate code, you have to know the intent of the project. You have to do software archaeology, follow our process on, doing the class diagrams and see what it's actually doing, what it's supposed to do, and stuff like that first. So anyway, I basically took, obviously I'm not going to get the source code for the compiler and the parser and the lexer and all that stuff that the R&D team has, and I'm certainly not going to be able to release it in the wild. So I'm actually using a open source parser and lexer that Jacob Thurman is maintaining as part of the Castalia project for his refactoring engine. And it doesn't generate a syntactical tree or anything like that. It just kicks back each token by itself. So in this case, let's just go and run it. Next computer, let's see. I think I clicked. There we go. So take the source code here. There's 124 files. See if it processes those. So what it does basically is go out and finds every single token, and then the ones I care about, it builds up in the list at the bottom. So I can just see that I used 145 units, and then add accepted used 47 times in those files. I got 124 files. 155,000 lines, maybe that's interesting. Maybe you have 20% in one file name, somewhere like that. Maybe that's the target. We've got pointers. So 11% of those are sitting in the fax conversion file. Actually, if you add up the three top ones that have to do with faxing, there's probably 25% of all the pointer operations are in there. So maybe that gives you a point of interest. Maybe that's going to be harder to port than anything else. I search for string, read, write, char, basically everything from Nick's article as far as how to unicodify your project, edges of your application, things like that. Ampersand operator, for instance, 20% of those are in that fax CVT unit again. Maybe that's of interest. Get proc address. 44% of those calls are sitting in some utility unit. 35% are sitting in some other utility unit here. I just added this one yesterday actually to add some tokens in here. You can put in your custom tokens if you want. To this tree, process it again. And then those will be part of this tree. So basically this tool is just slightly smarter than grep and count, to use some Unix names. So here's a get temp file. Here's my 6 instances of get temp file name, the ANSI version of that. So anyway, it's slightly smarter than rep and count. I don't guarantee anything. I'm going to put it out there. If you play with it, if it helps you, let me know how, and we'll see where it goes. You can save the report, just a text dump on this file. All right.
Cool.